In this video, we're going to learn how to read a text file into Python, do some manipulations with the contents of that file, and then write the output of our manipulations to another text file. You can see that here at the top I have added a line that says from future import division. We're not actually going to need that today, but I'm going to recommend that you start putting it in there because at a certain point you may find that this is something you need when you do different kinds of mathematical operations. And if you want to learn more about it, here I've put a link in where you can read about what it is and what it does and why you might want to use it. The text that we're going to be reading into Python today is a transcript that comes from the childless database. And I've put a link here where you can find this text. And here you can see what the file looks like when you just open it in a text editor. The first thing we need to do is to find the path to the file. Here I've saved the file on my desktop. And the way you find this path will differ depending on what operating system you're using. But whatever you do, you need to find the path that tells the computer how to find that file. So here we have created a variable f which contains the path to the file. The next thing we're going to do is to create another text file where we are going to store the output of our manipulations. And you can actually just get Python to do this for you, but I think it's nice to create it manually here so that it's very clear where it is that we're going to write out the information that we get from our script. So this is just a completely blank, completely empty txt text file, which I have called output, and I've saved to the desktop. And just as we needed to give Python a path to the file that we are going to read in, we also need to give a path to the file that we are going to write to. Next, we need to make the file available to Python to do things with by telling it to open that file. And then we're also going to need to ask Python to read the contents of that file in. And then finally we can just use print to check that it has done what we wanted it to. These variable names, file and ftext, might not be the best ones. You can probably come up with something better yourselves. So let's just type print and check that Python has read the file in correctly. So this all looks pretty good. This is easy to read by a human. But what we want to do today is to remove some of these lines of this file to clean it up a little bit. And to do that, we're going to want to make it a little bit easier for the machine to read. So since we're going to want to remove lines, it'll be useful to split the file into lines. So that's what we'll do here. We'll create a new variable lines, and we'll use that same split function that we've seen before. But now instead of splitting on the periods at the end of sentences, we're going to use the \n delimiter to tell it where to split. \n gives us a new line. So I'm just going to add some comments here so that we can remember what these different lines of code do. I should also point out that \n is the delimiter for a new line. It tells Python that to look for the end of lines of text. But depending on the system you're working on, you might need to use a different delimiter, like \r\n, or possibly \r. So you'll just need to try to see which ones work for you. So if you look down in the output of our print command here, you can see this \t. This is another one of these codes like \n that are embedded in the text, but we don't normally see them when we just read the text in the text editor. \t is a tab indicator, a tab delimiter. So let's just get rid of that too. Why would we want to get rid of the tab indicator? Well, because later on we're going to be wanting to count things in our text, and tab and new line aren't things that anybody actually said. They're just formatting indicators, formatting delimiters. So when we're going to be counting items in our text, we don't want to have that kind of stuff messing us up. So you've already seen how you can use the replace command to replace items, either with something else or just with nothing. So that's just what we're going to do again here. You can replace just anything you want in the text with anything else that you want, or with nothing. So let's say you want to get a file where the only things that it contains are things that people actually said. You want to get rid of all the syntactic parsing, you want to get rid of all the ID numbers and encoding stuff. Now remember, you're not throwing this information away. You still have the original text file, and you also even have a variable stored in memory, ftext, that has all of that stuff available to you if you want it. But you might want to create something that has just cleaned all of that stuff out. So we just use the @ symbol as a way to identify lines that have ID numbers and other metadata that we want to clean out of our new file. And if we want to get rid of the lines that have parsing data in them, well, one of the distinctive features of those we can see are these vertical pipe characters. So let's use that as an identifier for parsing lines. So now we have a script that reads in the transcript file. It splits it by each line. It then replaces all the tab delimiters with nothing. It has removed the lines that have an @ in the beginning of them, the metadata lines, and it has also removed the lines that have the vertical pipe character in them, which are the syntactic parsing lines. So now the next step is to write out this new file to our output file that we created back at the beginning and saved on the desktop. Okay, so let's go through these lines of code one at a time. The first line, with open path out a plus as file, colon. Well, what this is saying is take that file, the output file, which we told it above, we gave it the path and called that path out. Take that file that you can find by following path out and open it up, in a particular way, and we've indicated that particular way as a plus. There are different ways that you can make a file available to Python. It could be read only, it could be write only. There are a whole series of different ways you can make a file available. I'm just going to leave you to the documentation to take a look at those. But suffice it to say that a plus will work for our purposes here. And we've asked it to temporarily call that thing file. And by that thing, I mean the version of our output file which Python currently has available to it in memory. And we're going to end this with a colon. That lets Python know that there are going to be other things that we're going to want it to do while it keeps that file open. So the next line starts with a tab indent, and Canopy actually does this for you. That's one of the nice things about Canopy. If it didn't, you would have to make sure to put that in yourself, because otherwise Python will give you all sorts of errors. This is one of the things that drives people crazy about Python, because spacing and white space matters. So it starts with that tab indent, and then it says for s, comma, val, I've written that for value, in enumerate clean list, colon. So what we're telling Python to do here now is to essentially go through all the items in our list, clean list, one at a time, and then do something with them. And that something comes in the next line. So this enumerate command is extremely useful, but I think it can be a little bit difficult to understand until you start playing with it a little bit yourself. But I think one way you can think of it is that the S there, and we don't have to write S, we could write X or something else, but we're just telling it for each item in the list, take the contents of that item. So here value means the actual text that is in that line of the transcript, whereas S you can think of that's the line number, say, in the transcript. So for each line in the transcript, get the contents of that line. So if there's a line in the transcript where the child says ball, ball, then value in this case is going to be ball, ball. So in the next line we are creating a new variable, data, and into that variable we are putting the text that we got out of the current line in the transcript, val. So in the example, we're putting ball, ball into data. But ball, ball is currently not in a string format, and we want to make sure that it's in a string format because our eventual goal is to make a text file that we will be able to read. So now notice also that the line with data is also indented with a tab. And that's because we now have a second loop that is embedded in the first loop. So in the first loop, with open path out a plus as file colon, we are just keeping the file open while we do a bunch of stuff with it. And then in the second loop, the for loop, we are stepping through that list, clean list, one item at a time. And so for each item, for each line in that list, we are doing the same thing with it. We are getting the value, getting the contents of that line, and making it into a string, and then putting it into the variable data. So what that means is that the contents of the variable data is going to be changing all the time. Every time we go to the next item in the list, it's going to have a new value. So if we have a transcript with 53 lines, then data is going to have 53 different values, but it's only going to have one of those at a time. Then, each time we put a new value into data, and thereby erase the previous value, we're going to want to write that value to our output file. So in the case where data has the contents ball, ball, we've transferred that into a string, and now we want to write ball, ball in our output file. And we're also going to want to make that look nice and clean again. So what we're going to do here is we're going to say file.write, write something into that file. What are we going to write into the file? Well, first we're going to write data, whatever that is, whatever the current contents of data are. And then we're also going to write \n or \r\n if that's what works better in your system. So that's going to put a new line after the contents of data, and then the next time we get new contents of data, that will go on the line below. And finally, after we've done all of that, then we're going to want to close the file again. And notice that that needs to go, needs to be aligned with the original with open line, because now both of those loops are done and are closed. Okay, now that we've gone through that, let's try running our script and see what happens. At first, nothing seems to happen, but let's go check the output text file and see if it actually has written things there the way we asked it to. And sure enough, what we now have is a transcript without all the metadata and without all the syntactic parsing, just with the spoken words. Actually, it's not just spoken words that are left in this transcript. So as a little challenge to yourself, you could see if you could remove some of the other tiers also. And finally, I'm just going to leave you with some links and information here, and also a final challenge. How could you modify this script, or parts of this script, to obtain only the child's speech? That's it for now. Try some of these things out for yourselves and see if you can't get them to work.